The first principle is stability, which says the lower the center of mass, the larger the base of support. The closer the center of mass to the base of support and the greater the mass, the more stability increases. In this, you can see that Eric has crutches and his feet placed so he is in a 4-point stance, giving him a lot of stability as he is closer to the ground. He has a large base of support and his center of mass is close to his base of support. Here you can see that Eric's base of support is very close together and he is standing straight up, so his center of mass is far away from his base of support, giving him very little stability and making it very easy for me to push him over. The second principle is the production of maximum force. The production of maximum force requires the use of all possible joint movements that contribute to the task's objective. In this video, you can see that Eric does not turn his hips or use any of his other joints besides his shoulders to get power behind the ball. That's why he's not hitting it very hard. Whereas in this good example, you can see that I am twisting my hips and my shoulders and using my whole body to put pace behind the ball. I'm using all of my joints so that I can hit the ball stronger and achieve maximum force. The third principle is sequencing of joint rotation, which says that the production of maximum velocity requires the use of joints in order from largest to smallest. Here you can see that I am not using any of my joints. I'm simply standing with my feet together and using my arm and my shoulder to throw the frisbee. This is not a very effective method. Here, Eric is using his whole body. He's twisting his hips and his shoulders using big joints, and then at the end he's using his arms and extending of his feet to use small joints for maximum power. The fourth principle is the impulse-momentum relationship. The greater the applied impulse, the greater the increase in velocity. Here you can see that Allison is not putting too much force behind the ball. She's not taking any steps and her feet are still. She's only using the strength of her upper body to try and hit the ball with power and speed. Since I'm running and jumping into my serve, I will have a lot more momentum behind me than Allison did as she stood still. Therefore, the applied impulse will be greater. The fifth principle is called the direction in which movement usually occurs, which says, movement usually occurs in the direction opposite that of the force applied. In this, you can see that the force applied in the opposite direction, being Eric's arms, was less than the force applied from the ball, so the ball didn't actually bounce off of his arms. Here you can see that the movement occurred in the opposite direction of the applied force. The ball applied force on my arm, which caused the ball to have an opposite reaction and come off of my arms. The sixth principle is the effect of a force acting at some distance from an axis, which is angular motion is produced by the application of a force acting at some distance from the axis, that is, by torque. In this video, since I'm hitting the ball with my wrist, the perpendicular distance from the fulcrum at the joint is smaller than if I were to hit the ball with my hand. Therefore, the torque is going to be less because there is less distance from where the force is being applied. In this, since Eric is hitting the ball with his hand, the perpendicular distance is greater. Therefore, the torque around the joint is going to be greater. The last principle is the conservation of angular motion. Angular motion is constant when an individual or object is free in the air. In this video, the ball being the object, it was spinning at the same pace when it was in the air and after I hit it. Therefore, the angular motion was conserved.